Hello everyone, my name is Vivek and I am a software developer. I have done my BTech from Maharaja Surajmal Institute of Technology, Delhi in electronics and communication background. After that, I have done post-graduation diploma course which is PG DAC from ACTS Pune. So the project which I have chosen is online quiz application system, which is a backend project on Node.js using JavaScript and Express framework, and the ORM which I have chosen is Sequelize using MySQL. Let's understand the problem statement of our project. Our project is online quiz application system, which is a backend project. So in this project, we can have multiple quizzes. In one quiz, we can have multiple questions. In one question, we can have multiple types of question like single option correct question, multi option correct question, and text based question. In single correct option question, we can have only one correct answer. In multi correct option question, we can have more than one option correct, and in text based question we have to type text from our keyboard. And after that we have a feature to submit the quiz, where we can submit the quiz and get the total number of the question paper and the marks obtained in the quiz. Now let's iterate to the list which I have made for the discussion about this project. We have already discussed about the project, that what is project about, what is the problem statement, and other we have to discuss overall flow of the project. Then we will go to database design, then we will go to API design. Then we have two most important thing which we have to discuss in this project. First, the algorithm for saving question in database, and the second is the ends problem of the project, which is submission algorithm, like submission of the question and getting the obtained marks and total marks. Then we will run all the APIs of the project, run all the test cases of the project which I have written. Then we will do walkthrough of the GitHub repository and see the readme, what I have written in the readme content, and how we can access and set up the project and run the APIs. And after that we'll see the future scope of the project. So we are done with our first topic, which is about the project. Now before going to overall flow of the project, let's see that what things I have prepared for the explanation of the project. So we have this canvas where I have made everything, every prototype of the website, that how the API will work. We will discuss this, everything I have. And after that I have DB design, that how the DB schema is looking and how the relationships are built among all the table. After that we'll see the important queries of the project, which is important to understand the algorithm of the project, that how internally APIs are working and they are filling the database as tuple. After that I have add question flow diagram, that how the addition of question in the database works. After that I have a flow diagram of how the submission works, because in submission we have the actual engineering logic, which is the most important part of the project. After that I have a sequence diagram, which is important to see the overall flow of the project, from posting quiz to posting question and answer to submitting the quiz. Everything is mentioned in this sequence diagram in perspective of the controller, service, repository to DB layer. And after that I have my GitHub repository and the readme file which I have made. And after that I have code setup that I have written for this project, and we have postman setup, and again we have the SQL queries. We will run it to see the logic of the DB, that how data is saved in the DB. Now let us discuss overall flow of the project. I have a prototype of UI where the APIs of this application will be consumed. If we understand the UI first, then it will be easy for us to understand the APIs, why they are designed so. So let's see that what do we have in our quiz application. In our quiz application, we have a list of quiz and an option to add a new quiz. We can add it from here, and in a quiz we can add questions, and the last we can take quiz. Now let's get started with the adding quiz, that how we can add quiz and the UI will go from one to another. Let's see. We have this UI where we have option to add the quiz. First we will write the name of our quiz. Suppose the name of our quiz is general knowledge quiz. We typed general knowledge quiz and we added quiz. So the UI will shift from this to this, where the general knowledge quiz will be rendered in our screen. And now what we can do, we can add a new question in this quiz. To add the new question in a quiz, what we'll do, we will click on this button, add question. After that, UI will be prompted again. In this UI, we know as we have different type of questions, so the UI will give us option to add different type of question. Like I have added the name of the question and the option corresponding to this. As this is a single type of question, so one option will be correct, so we'll add the correct option in this and we will save it. As we will click this save button, a post request will be made from our application to the database, where this question will be saved with the answer in one go. And next we have a second type of question, and third text type question, where a user will be allowed to type text. And one important thing for this project, I have kept the text type question very simple, like number of days in a week. We know in a week we can have only 7. After we added all the question, what we'll do, we will click on done. As we click on done, our quiz with the question will be saved and it will be rendered on the UI. Next step, what we can do, we can go to the home page and take the quiz, because the questions are added in our quiz. So this is the UI again where our quiz is added, so we can take the quiz. We'll click on take quiz. After clicking on the take quiz, again we will have the UI where we have number of quizzes and we can start any of the quiz. After we click on the start quiz, we will be prompted with the UI where we have the questions corresponding to the options, where we can choose our option and we can proceed our quiz, and we can submit it and get the total marks of the quiz and what marks we scored in the quiz. So this is the overall flow of the project, that how the APIs which I have made in the backend system of online quiz will be consumed in the UI. Let's see the database design, that how database is designed and what entities we have in database and how the relationship between the entities in database. We have quizzes table, we have questions table, we have answers table, we have submission answers table, and we have submissions table. In quiz table, we have a property title, that what is the title of the quiz, like JavaScript quiz. In questions table, we have the quiz ID. One quiz can have many questions, so the reference of that quiz I have stored in the questions table. And I have the text of the question, that what is the question about. Suppose if we have a calendar question, so number of days in a week, so this is the text of the question. And I have a type property which is enum. Is it a single choice, multiple choice, or text type? And we have a points property which is the marks of the question, like this question is of 4 marks, and the negative points, if any question has negative points, like if you do the wrong, you will get the negative points. And then we have answers table. One question can have many answers, like in multiple choice question, one question have 4 choice, so we can have 4 option. And we have the text of the answer, and there is a is correct property. Like we have a single choice question where there is 4 option, so one option is correct. For that I have maintained this is correct. Now let's move to the submission answer. So what is the requirement of this table? Let's assume we have built the quiz, question and answer, and user is in a stage to take a quiz. When the user will take the quiz, user will choose a option from the available option. Again, for another question that is multiple choice, he or she will choose more than one option. And if the text based question we have, he or she will enter the text. So when the user will choose any option or enter the text, we have to persist this in the database. that we know that okay, this is the right option or wrong option we have, but what user has chosen we have to persist that, so that when calculating the marks we can match the selected option by the user to the correct option which is saved in the database. For that, this table is required. And again, we have the submissions table. So in submissions table, we have a quiz ID that this submission belong to which quiz, and we have the score which is obtained in that submission, and what is the total score of the submission, which will be the sum of the points of all questions in the quiz. And one thing more, in case of the multiple choice question, I have tackled it in very good way that in the first tuple only I will store the mark. If he or she gets the positive or negative, no partial marking will be given to all the tuples. I'll discuss it when I'll discuss the submission of the table. And one more thing, we have submission, we have selected answer ID and we have text answer. So how we will use all this? When the question will be of option type, then we will store the answer ID in this selected answer ID, which will be the ID of the option. And when the question will be the type of text, then we will store the exact text which user entered in the UI. And then when calculating the answer, we will compare both two. Now in terms of tuples, let's also see that why submission table is required. Suppose I have this tuple where this belongs to ID 13 belong to the first submission, and after ID 13 it's belong to the second submission. If we will not have this submission table, so we will not have this IDs 1 and 2. So when we will compute the overall marks, all marks will be added. So in that case, to segregate that, these all tuples made, there was a submission with ID 1, and these all tuples were made when there was a submission with ID 2. So this is the use case of submission table and submission answers table. Till now we have seen the database design, and now we will see the API design of our project, that how I have designed the API on the basis of what. So for that we will again take our prototype of the UI and understand on the basis of that, because at the end our APIs will be consumed by the front-end client only. So let's see. As we know, this is our the home page where we will add the quiz. First thing, we have to add the quiz, then only we will be able to add the question, then only we will be able to add the options. So what is the API? To add the quiz, we will hit a post request with the endpoint API v1 quizzes. I have versioned the API because this is our first version of the project. If in further go, we can make it v2, so that APIs will be segregated in different versions. So we will do a post request with the endpoint this and headers content type application JSON, and we will add a title in body. As we know, this is our table of the quizzes in which we have title, so we have to add the title in the body, and this will be the response of the UI. And response, why I have sent the created at updated at also, because suppose if the client wants to filter something, that when it was created or when it was updated, so our quiz is added, we have to add our questions. We'll click on this add question. So on clicking to this add question, we will go to a new page where we have to add our questions. So in order to add our question, we should have our quiz ID and text, type, points and negative points. These parameters we should know. So as we have clicked on this add question, and this button redirect us to a new page, so in the cache of the front end, we will have the ID of the quiz, and we only have to add the text and options and the correct options of the quiz. So we will add the text, we will add the options of the quiz, and we will add the correct option of the quiz. And same for the multiple and same for the text based. and as soon as we will click on this save button, a post request will go. So let's see that post request. We have a post request with APIs v1 slash questions, and in body we have this payload. So let's understand this payload. We have question ID, we have text, we have type, that this is of single type, we have points, and we have negative points. And in this payload only, I have sent the answers in an array where there is a text and is correct property. So I think this is the best way, because in one go only we can post a question in one payload, and in service layer we will write logic to add the question in the question table and these answers as tuple in the answer table. When we will see the service logic, we will see what logic we have to do this, and at the end what we will get, the success response of the question. I have added this screenshot of the first one only. The same will be the success response for this multiple choice and text based question. Now we have to start the quiz. In order to start the quiz, what we want to have the list of quiz we have. Then only we will able to select the quiz, that which quiz I want to give. So for that I have a API. When I'll click to this button, take quiz, I should be redirected to a page where I have a number of quizzes. So this is a get all API where API v1 quizzes. If I'll hit this API, I'll get a list of all the quizzes, and we can populate to page of the UI. So we have populated this in this page. Now what task we have to do? We have to start the quiz. To start the quiz, we have to have all the questions of the quiz with the corresponding options. But one thing we have to keep in mind, that we should not pass the correct option property in the payload when we will hit this API. If we will give the correct property, then there will be no point of the quiz, because user will eventually get to know that which option is correct. So when we will process this request, we will process the is correct property, and we will not send it into the payload. So after this payload, we can populate this into the UI. So in our UI, the all question with the options will be populated, and user can select the options. As we discussed above, that as we select the option and we will submit the quiz, the submission table will be made and submission answers table will be made. Tuples will be created in both of the table. Now let's understand how the tuple will be created, which table will be created first. So we will do a post request. The payload of our post request is quiz ID, and we have a array of answers in which we will send the question ID and the selected answer ID. And here we have a multiple choice question. So how the flow will go? When we will do this post request, we will get a response where we will get the quiz ID and the total score of the quiz, that what is the total point, adding up the point of every question, and to scored obtained. So how the calculation will go? We have to discuss this submission part, and after this submission there will be a total score and total score obtained. So now let's understand how the addition of the question work. What thing we have to discuss, that how we will add this question in the table with the corresponding answers. This is the first thing we have to understand. And the second thing, that how the submission will work after we send this payload to our Node.js server, how it will handle the submission, and will give the response back with the total score and the scored obtained. Now let us see the algorithm for saving question in database. So this is the flow chart, that how the questions will be saved in the database with answers. First we will see the flow chart, then we will go to the code and see how the code is written, how the service layer manages to do all these. First of all, we'll start receiving question creation data, the payload. This one, we'll get this payload first. After getting this payload, we'll start a DB transaction. So why I have used this DB transaction? Because I want atomicity in the whole process. Let's see why atomicity is required. Suppose I'm adding a question, and after that I have to iterate to each answer and have to add each answer. In between something goes wrong, something goes sideways. So what will happen? Our DB will be in the inconsistent stage. Suppose question added and we added only two options, we will have to perform this again, and again this question will be added, and the options will be added. So our DB will be not in good stage. So what we want, if something goes sideways, we want to roll back, we want to uncommit all the changes which happened in the DB. So what we will do, first receive the question creation data. After that we will start the DB transaction. In DB transaction there are two things. If this is our happy path and this is our sad path, is if something goes sideways, we will catch the error and roll back the transaction as we discussed. So what we'll do first, we will validate our input, that do we have quiz ID present, and again we will go if quiz ID present. If it is present, then we will go this way. If it is not present, then we will throw error that quiz ID is required. And again we will validate question text present. If yes, then we will again go to this, that question type is present. Yes, type is present. If type is present, then these type are valid types, like single choice, multiple choice, and text. Whatever enum we have kept, single choice, multiple choice, and text. If our type is valid, do we have answers array? uh, if not, then we will throw error. If yes, then we will proceed further. At last, what we have to check, the main thing, suppose we are adding the answer array in the payload of adding question. So what we want, that at least one option of that question should be correct. If not, then we will throw error. If one option is correct, then we will proceed and we will create question record within transaction. We will create that question, we will create a tuple in the question table with the record of that question. We will use the text, points, negative points, everything of this payload, like quiz ID, text, type, point, negative point, and we will save into the question table. First we will do this. Then what we will do, we will iterate over each answers in data answers. So what we will iterate on, we will iterate on this array. We'll go to this first, then second, then third. And what we will do, now we will add this in this answer record, and we'll make the tuple in the answer table. After that, we will return questions with the answer with find by primary key, and we will commit transaction, return the created question with answers. What we did here, we returned this. So this is the overall flow of our question, and now we will see how I have written code. So for this, we will start from index. We will go to API route. After API route, we will go to V1. In V1, I have questions route. In questions route, I have this validation, create question. I have written all the validation for all the property. So in the middleware, let's see, middleware question validator, every validation is written, that do we have quiz ID, if question text is present, not what we discussed in the flow diagram. The same thing I have written in code. And now let's go to routes, question routes. And what we have, we will go to question controller dot create. When we'll go to question controller dot create, there we will call question service dot create question with answer. So let's go to the service layer of the question, question service. So how the flow goes, First of all, we will start a transaction as discussed above, and we will create a question. So from here we will call the repository layer, and we will call dot create method, and we will create the tuple in the question table. Then what we will do, we will loop over the question, and we will go to the answers array, and we will create the tuples in answers table of the corresponding answers. And then what we will do, we will call the repository layer, where we will call a function find by id with answers. We'll go to repository layer, and we will call this, let's go to repository layer, find by id with answers. We will call the function to get the all questions with the answers. Now let us understand the submission algorithm of the project. What we have all things set up, and we'll do a post request with the payload of quiz id and an answer array. So how this will work, first of all, this payload will come from postman, and it will go through the routes layer, controller layer, and at the end to the service layer, and we will receive this payload in the service layer. So how we will proceed after this, first of all, we will receive the data in the service layer. After that, we will start in transaction. In transaction, first of all, we will fetch data.answer.map. So we will go to this data, and in the answers array we will map where a dot question id. We will choose all the question ids from this answer, and we will save in the array. So how array will look like, it will look like this. So after that, what we will do, we will call our repository layer and find all the questions with answer. We will add this data.quizid and all the question id corresponding to this quiz id and the questions id which are in our payload. We will find all the question. So how it will look like, it will look like this. We will get a response from the repository layer, where we will have this data value, and we will have some previous data value and this unico. These are the metadata that we will get from the Sequelize ORM. So what we want to clean up our data. So we will call a map over the to.json method, and we will clean up our data. After cleaning the data, our data will look like this. We will get all the quiz questions in an object format, where we have the question id and the quiz id and corresponding all the details of the question. As we get our the object of question, now we will create a submission record with the initial score and total set to 0. Why we are creating the submission record with the value 0? Because further we want to add the data in submission answers table. There we have to add submission id. For that we need to have our submission id ready first. That is why we are creating this. After creating our submission table, we will initialize a total score, obtained score, and submission answer record, that is an empty array. After initializing this, we will loop over payload answers, like this is our user answer first, then second, then third, then fourth, fifth, 5, 6, 7. And what we will do, let's assume that our iterator is on this user answer. We will try to find where our q.id is equal to user answer.question id. So this is our user answer.question id, which is 1, and we will find q.id. We will loop over this question, quiz question. So this is our quiz question, and in this quiz question we have our objects. So we will find that, do we have 1 as question id here? Yes, we have 1 as our question id. After this, if it gets equal, we will proceed. So what we will do, in order to have the total score, as we have initialized this, in total score we will add the question dot point, that what point do we have. As we have 4 point, we will add this and initialize a result variable. After initializing the result variable, we will check the type of the question. After checking the type, if it is of text or single choice or multiple choice. Suppose this is our question 1, it is of single choice. So let's go to the function of single choice. In single choice, what we have to add, we have to add our question, user answer, and submission id. Let's go to this function. This is our single choice function, where we have add user answer and this question and submission id. What we will do, we will check from question dot answer dot find that in this answer do we have any is correct. Yes, obviously we have. We can go to the table and find. Yes, we have a correct which is of id 1. We got correct answer id, and then we will check user answer dot selected answer id, this one, that okay, we also have answer id is equal to 1, so both are equal. So what we will do, we will parse float question dot point, that what point do we have in question. We have 5 points. If it is equal, then we will allot the 5 points. If it is wrong, that if this 1 and 1 does not matches, so we will allot the negative point. Here in this case we have both the ids equal, so we will assign score as 5, and we will return the score with submission answers array. I have put an object inside the array because in multiple choice question we can have multiple answers. In that it will be useful and consistent over all the returns. So we will return the submission id, question id and everything with the score. After this we get our result, and after getting the result we will add obtain score as result dot score. We obtained 4, so we will add 4 over here. And in questions answer record dot push, we will whatever the existing values in this record we have with the submission answers result. So what is that? So this is our record submission answer. Here we have the result. This is the result, this is submission answer. This will be added in submission answer record. After that we will iterate again this, and this is again single choice question. Let's discuss a multiple choice question, that how we will handle that. Suppose we have 3 question id which is a multiple choice question. Again we will perform everything and we will go to the multiple choice question function. We will try to calculate the correct ids from question dot answer dot filter, and we will map it to answer dot id. We will store all the correct ids and we will store the negative point of the question. Suppose the ids are 3 correct ids, a, b and c are the 3 correct ids, and the negative point we have is -2, and the point per correct. This is the important thing we have to calculate. Suppose the positive point are 4 and we have 3 correct ids. So how this 4 will be allocated with all these options? We'll have to do 4 by 3 length. So this will give me the individual option partial mark, and we can allocate it afterwards. So we will find the selected ids. After finding the selected ids, we will see has wrong selected. We will check if there is any option which is wrong. If that is wrong, then we will make this boolean true, and we will make let question total score be 0. And what we will do, we will check if the has wrong selected, then we will add the negative marks. If it is true, then we will add the points per correct, this is points per correct, into the selected ids dot length. Suppose the user selected a and b, so we will do this 8 by 3 will be the marks, that partial marks that user will be getting for this question. In submission id we will add both question a and b as our record. And now the main thing comes that are we adding the partial mark or we are adding 8 by 3 to one question only. So what logic I have written is, when the id is 0, suppose I have to make tuple for a and b in submission answer. So the first question that will be encounter, I will store 8 by 3 in this only, and corresponding to all which are left I will store 0 0 0. If there are 3, there are 4, and same for the negative mark also I will add. If it was wrong, suppose our this boolean has wrong selected is -2, so in the first record only I will store -2, and in other record I will store 0 for the consistency. And after that we'll return the result total score and submission answers. Same for the text. If suppose I got the text answer, so this is the text answer I got, const int, suppose for this question id 6. Let's do dry run for this question id 6. We got the question dot answers. We will filter is correct one, that in this question here we have question dot answers, question dot answers. Suppose this is the 6th one. From this we will do filter. Okay, we got this one correct, this one correct. After that we will map to text dot lowercase, and we will trim if we have spaces pre and post to the characters, and we will make this correct text. And after that we will find the is correct, and for this we will do user answer dot text answer, store this const, and we will try to see if correct text dot includes this or not. If correct, if this exists and correct text include this, then we got the correct answer, so we will make this is correct boolean true. And after that we will do scoring on the basis of that. If we have is correct true, then we will store the points, otherwise we will store the negative points in the question, and we will return this. So after all, we will have our result array created. In this we will have all the submission answer, because at the end we want to add all this submission answer table. For that I have created this array, and after that I'll call the repository layer and do the bulk request. And let's see what is this result, how it looks. This is the result. We will do bulk request in repository layer with all the data. And after doing the bulk request, we'll update the submission dot score. In submission we have score, we are maintaining this submission dot score. And after this we will update the submission dot score equal to obtained score. In submission we have that score property, we will update that, this one score, we will update this. And after that we'll update submission dot total also, that what is the total, because we are accumulating over each iteration. And after that we'll save this submission, we'll again save this submission with the values of the score obtained and the total score. After that we'll commit the transaction, and after committing the transaction we can return this back. So this is overall flow of the submission. And let's see flow diagram. So again what we are doing, receive submission data, initializing a db transaction, after that extracting question id from submitted answer, and again we are initializing total score is equal to 0, obtained score, creating a submission table, iterating over each according to the algorithm which we saw. We will create and end the iteration, and again we'll update the submission table and create the bulk request and save the submission, commit the transaction, and return the quiz id, total score, and obtained score. Now let's check this. I have added all the things, questions and answers, quiz. Now hit the API. So we are getting our submission recorded successfully. Now let's check that what record do we have. This is the submission ID from 3. We have stored this 5 and we got the -1 for the single option. And we can see this is the question ID 333, and we got the marks only for the first tuple, not for the second and third. Again for the fourth question we selected 2 option only, so we got the partial mark of 8 in the first tuple only, and the next tuple is 0. In fifth one I got the negative mark because I chose the incorrect option, and same for the text one 5 and 6. So why I am saving this like this, because consider a situation like this, that we have many submissions and user want to see their score with quiz id and with question id and selected answer. So in that case we want some API with the payload, so that we can render those data in the UI and show the user that what options for the question they have chosen. And one more case, if we want to show the total marks to the user, so in that case we need not to join the tables and calculate every marks again. We have the scores in the answers table, we will just sum up the score and show the total score and the obtained score. So this is all the overflow of submission. Now let's run some important APIs of the project. First of all, I'll turn up the server. Server is turned up, and I have made a list of important JSON that will be required for our post request. So let's go to the postman. Here we have an API for create a quiz. So we have the payload in body. Let's create a quiz. So we got a quiz created. Now let's get all quizzes. So as we can see, our quiz is created. Now let's create a question. So I'll choose this payload and create a question, and with the required option. Now let's create the question. Now let's create the third question. Now let's create the fourth question. Now let's create the fifth question. Now let's create the sixth one, and the last seventh question. Till now we have created our question. Now let's check that we can get all the question or not. So we have this API v1 questions, and I have used quiz id is equal to 1 as a query params, because we are trying to get the question on the basis of the quiz id. So let's hit the API. So here we have all the questions with the options, and one thing we can notice that we don't have here the is correct property. That is desired because we don't want our user to see the correct option, then there will be no point of having a quiz. So we got all the questions with the options. Now let's submit the quiz. So this payload I have created, in which I have quiz id is equal to 1 and array of answers. So how I have designed it, I kept one question to be correct, this is correct, this is wrong, and in the multiple choice question, one payload I have added all correct, and one of partial, and one question with the wrong answer, so that in submission answer we can see how the data is stored and we can visualize each of the cases. Let's submit the quiz. We submitted the quiz and got the result, total score to be 57 and the obtained score 26. Now let's see how tables are made. First we can see the submission table. As we can see in our submission table, we have an entry of quiz id 1 and score and total marks. Let's see submission answer table. So as we can see, the first option was correct, so we got 5 marks, and the second was wrong, so we got -1, and in third one I have all correct. So how the data is populated here, I have populated the total marks in one of the tuple and other I have kept 0 for the consistency. And in the question id 4, we have partial correct, so we get the partial mark 8 and other to be 0, same as we discussed above. And in the negative case also, in question id 5 we have one wrong answer, so we are getting -3 in one of the tuple only, and next to all these we have kept 0. And in the text option we also got the 8 marks because the positive mark of that question is 8. So this is all API which is used in this project, and these are the important APIs. Now let's run all the test cases which I have written in the code. I have used jest library for writing the test case, and I have used the feature of code coverage, and I have implemented jest HTML reporter to see all the logs of the test in UI. That is more elegant than the prompt that we get on the console. So let's run the test. So as we can see that our all test case is running and the code coverage is good. I have tested the question service, quiz service, and submission service. So around all these we have all green, the test coverage is good. Now let's see that what test I have covered. So these are the list of the test cases that I have run. I have run in the submission service, I have run test case in quiz service, I have run test case in question service, and I have run test for the common utilities like submission util, because I am using this submission util in the submission service. And I have run all the positive and negative test cases. Now let's do walkthrough of the project, that what file and folder structuring I have done and what architecture I have used. So first of all we have this index.js, which is the entry point of the project, and I have made this composition rule which manages all the dependency of the project like repository management, service management, and controller management. And further, when I need all this object, I am using from this only to my controller, service, and repository layer, injecting in the constructor. Now start with the routes folder. I have mentioned v1 route so that if further we do v2 route, so the routes can be segregated from each other. Here we have question routes, quiz route, submission route. After route we have our controller layer, where I have this info controller to check the health of the controller, and the question controller where I have all the functions inside the class and I have injected the dependency of question service. Same for the quiz controller where I have all the functions for the controller and I have injected the quiz service here, and the same for the submission controller. After the controller layer I have the service layer. Let's go to the service layer. Here also same, I have all the function proper commented out and dependencies injected from the composite root. Same for the quiz service, same for the submission service. Now let's move to the repository layer. In repository layer, I have made a file named CRUD repository where I have mentioned all the important functions which are regularly needed so that we can write it once and use it how much time we want. I have made the answer repository where I have extended it from the CRUD repository and called the constructor of the super. Same for the question repository. Here I needed some more function from those of the CRUD repository. That is why I mentioned more function here. After this, I have quiz repository and submission answer repository and submission repository for the same. After this, I have the config file where all the configuration is managed. After this, I have a utils folder where I have common folder of enum and response handler. I have made a response handler once and I am using every time this in the controller layer. And we have submission util for the function segregated for the submission service, and I have a error folder where I have app error and one error handler which is a global error handler. From any of the file in the project, if you throw error, this will handle the error and it will pass to this response handler where error response will handle and throw it. So this is all about the walkthrough of the project. Now let's see the sequence diagram of the project. This sequence diagram consists of all the important steps that we took in the project, like from posting a quiz. It is going from API router to controller to service layer to repository layer to database layer and giving the data back to the client. And for the posting question with answer, the same, we are going from API route to controller layer to service layer to the repository layer and to the database layer, and we are inserting question. The same we discussed above, that we will create a question first and question will be returned, then for each answer in the question we will add it into the database and we will return the same. And same we are doing for the submission of the quiz. We are going from router controller to service to repository layer, and we are doing all the functions which is mentioned here. And at the last, if there is any error, we will roll back the transaction and throw the error. This is all about the sequence diagram. Now let's walk through the GitHub repository. So this is the GitHub repository where I have segregated everything in the branches, in master branch, dev branch and test branch, and I have the readme file setup. Here what things I have in readme: I have about and important links and project setup guide and the important APIs which is mandatory for this project. So this is a clear and crisp about section, and these are the important links for the project like database diagram, sequence diagram and the flow diagram for both addition of question and submission of the quiz. After that, there is project setup guide where all the steps are mentioned to set up the project, and after that there is important APIs with the corresponding method endpoints and the request and response JSON. So everything is mentioned here. And these are my commits which I have done while doing the project, starting from this till this. Now let's talk about the future scope of the project. So till now our project is just a normal quiz system. There is no user option. So what we can do further, we can integrate a user table. In that we can reference it from the submission table, so that one submission will refer to the user, and there we can do authorization and authentication, everything, and there we can do authorization and authentication. And now our project is in very small scale. If we want to upgrade our scale, what we can do, we can implement the load balancers, a rate limiter, all the resilience thing that we have. We can include the cache feature, so that every time we want some data, we need not to query from the database, because database operation is very expensive. These things I think which we can do in our project to scale our project up. So thank you so much. This was all about our project explanation.